Okay, so last week we talked about converting mega, kilo, those prefixes. Now we're going to talk about converting units, like inches to feet, inches to meters, inches to kilometers, all of those. And this is a common thing that you're asked to do in chemistry. So it helps if you have a firm foundation in getting this all set up. I have students who really like conversions. So I'm not trying to say it's horrible. I love conversions because it's like one of those things that you can do and you know you're going to get the right answer. Everything just lines up. It requires you to set up your work in a way that is neat and tidy. When I was taking physics as an undergrad, they had like a physics resource center, kind of like our science resource center, but it was just for students that were taking physics. And so they had TAs there that would help you and tutor you. And so I met with one of my classmates, and there was another guy that was in our class that also went to the physics resource center. And so he said, "Oh, were you guys working on the homework?" And we said, "Yes." And he's like, "Oh, perfect. I'm working on the homework too. What did you get for this problem?" So my friend and I were, working through this problem. We're trying to show all our work. We're trying to show it clearly. And then we look at his work, and it gave me a headache. Like, I didn't teach at that point, and I'm just like, there were numbers all over, and I had no idea how they went together. Like, it was just, I'm like, I don't think. And so he was asking, "Well, how did you get your answer? This is how I got my answer." And we couldn't even communicate. So one thing I strongly encourage you to do is try to be neat and tidy with your work. And if it goes against your personality, it's just something that you kind of have to work on, but it will go easier. It's one of those things like having a neat and tidy desk. It does make things easier. It can be a little painful in the beginning to maintain it, but so I strongly encourage you to do that. Okay, so I show these dominoes to kind of show you how we're going to be canceling out units. The idea is if you divide like a number by itself, what do you get? 1, right? So the 2 cancels out, and you just get 1. So when we're converting units, what we're ultimately trying to do is to get those units to cancel out. And the way you get them to cancel out is by dividing them, multiplying. So like if you have inches and you want to convert to feet, you have a conversion factor, 12 inches equals 1 foot. You're going to end up putting what on the bottom? The inches, yes. So 12 inches, 1 foot. So now we're in feet, okay? So that's the idea. Now with the example I have shown here, these dominoes, in order to get out of 1 dot, if you look down here, I have a domino that has 1 dot and 2 dots. How would I get that 1 dot to cancel out? By flipping it. So sometimes with conversions, conversion factors, you have to flip the conversion factors, and you can do that. That's no problem. So, okay, now I'm no longer in 1 dot, but I'm in 2 dots. But I want to get to the 4 dots. So these are my conversion factors. And a lot of times I'll refer to conversion factors as CFs. And students will laugh because they might think it stands for something else, cluster, whatever you might say. Especially when they're doing conversions, they're like, this does not feel right. But, okay, so how would you use this conversion factor to get out of 2 dots and into 3 dots?
So you have to use the reciprocal 2 over 3.
Exactly.
So that the 2 will cancel and set you up for your 3.
Mm-hmm. Good. And I'm not concerned about the orientation of these. So if you're freaking out about which way the dots should be, it's not a big deal. I like that you're thinking about that, though. That's good. That'll be good for organic chemistry if we go on for that. Okay, so now we're in 3 dots, and we want to get to 4 dots. So we have one more conversion factor. What am I going to have to do with that? Exactly. Very good. So, great job.
And that would cancel out the.
Well, you're absolutely right. So this cancels out, 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 this cancels out. The unit that we desired was 4.
Oh, okay. So you can flip that last one.
Right, and then you would have 1 over 4. Good. Okay. So now we're going to see how this applies to unit conversion. So we have actual units, and units can be treated like numbers. So just like when we divided 2 by itself, we got 1. So when you divide a unit by itself, you're going to get that canceled out. So if we have a conversion factor that starts off in kilometers, and the question asks us to get to feet, we will be given conversion factors. These are the conversion factors that I will always give you. I will not give you the metric prefixes. So I won't give you mega, kilo, base unit, that whole ladder. But I will give you these conversion factors. So I'll say given conversion factors. Okay, so I have kilometers here. How am I going to use this conversion factor to get out of kilometers? You're going to have to flip it, right? So now we have kilometers to miles. So now if we stopped the problem at this point right here, we would be in miles. So you're closer to feet, but you're not quite all the way there. And I do have this happen. Sometimes students just get overwhelmed and they get lost in the conversion process and they just get one step done. Now if this was a 5-point problem, I might give a point or a point and a half for each conversion step that you have set up correctly, and then sig figs and rounding would also rounding in units in your answer. So each little thing that you do to show your work can give you partial credit. And that's what you'll find in future chemistry classes. The clearer you show your work, the more likely it is you're going to get partial credit. Okay, so where do we go next?
To the miles and yards.
Miles and yards.
So the reciprocal.
Good. So we have to flip this one, flip this one. Good, so kilometers, kilometers, miles, miles. Now we're in yards. We're not quite to feet yet, so what's the last step that we do?
Yards to feet.
Yards to feet. Good. So yards goes on the bottom, it goes here. Good. Okay, questions about this? All right, we'll get some more questions, I'm sure, when we start working through this. So if we go on to the next page, we have our first conversion problem. How many feet is 3 inches? So I give you the conversion factor, 1 foot is 12 inches. So we're going to use that as our domino. Now, keep in mind that you can write this conversion factor two ways. You can write it 1 foot over 12 inches, or you can write it 12 inches over 1 foot. Sorry, can't see that. What you do not want to do is say 12 feet in 1 inch. Does that make sense? It doesn't make sense. Sometimes it's very easy to do that when you're working quickly and you just move numbers around. So be careful, use your thinking. Does that make sense? And so 1 inch, really 12 feet? Just, kind of step back for a second and look at it. The other thing that I want to mention, 12 in inches and 1 in foot always stay together, so they don't get swapped around. That's what I did here. So as long as you have those same relationships, over or under, you're going to be fine. All right, so the first thing we're going to do is kind of sort out what we're given. Now this is a pretty simple conversion problem. They will get harder, so it's a good idea to have a process that you go through. So what are we given here? What information does this problem give you? 1 foot equals 12 inches. And then we're also given a starting quantity, right? Something that we are to convert. So this is 3 inches. And we're asked to find what? How many feet? So question mark, feet. And so, like Mauricia, is that right? Said, good. It's our conversion factor, 1 foot equals 12 inches. So this is all the information we have. So the first thing we need to do is sort through this. We've kind of done this step already. I'm just going to reiterate it. So we're given 3 inches. We're looking for how many feet. 1 foot equals 12 inches. The next thing, after you've sorted through the information, and keep in mind, some of these chemistry problems will have several givens. You might have a lot of conversion factors. You might have to it might take a while to sort it out. The next thing you're going to do is to strategize. And I have found that a solution map kind of helps with that. So when I say solution map, I mean you're starting off in inches. Where are you going? What unit are you going to eventually get to? Feet. Okay. We have a conversion factor right here that goes from feet to inches. So that's just going to be a direct conversion. It's just going to be one step. It's not going to be 5 steps to get there. So we're just going to do one arrow. So each arrow in these solution maps represents a conversion. Ooh, sorry. Like if you saw, we'll go back to page 18. If you go to this example that I had at the bottom, our solution map for this, you start off in kilometers. You're trying to get to feet. Is it a one arrow? No, it's going to be several arrows. So you're going to go from kilometers to miles, and then miles to yards. And then you can go yards to feet. So you can see how a solution map will be helpful, because it's very easy to lose your way when you're doing these, especially when you have lots of conversion factors and you have these numbers, and then at the very end you have to think about significant figures. So let's go back to page 19. So now we're going to solve. So the way you set up your solution you're going to put your starting quantity, which is 3 inches. So I'm going to put, so that's our starting quantity. I prefer to always put that over 1. So we're going to put our starting quantity with units over 1. Now, when you're first getting into chemistry, and maybe you're not one of those crazy people that has OCD, not real detail oriented. My husband always makes fun of me because I'm so detail oriented. Like, what are the units? What are this? And whether it's interior decorating or just noticing things outside. It's like, how do you notice all that detail? You have to pay attention to detail in chemistry. I will have students who, when they're first working on conversion problems, they'll just write down 3. Or if it's something like, if your starting quantity is 3.00 inches, let's say, when they write out their work, they'll just write 3. And that's going to throw you off for significant figures in the end. So don't be like that guy. Oh, we met in the Physics Resource Center. Try to be very, organized. Okay, so 3 inches. Now, how am I going to use my conversion factor to convert inches to feet? What do I need to do? So if
Your inches have to be on the bottom.
So our inches have to be on the bottom. So we're going to use this conversion factor, right? Okay, so 12 inches, 1 foot. So now our units cancel out. So when you enter this into your calculator, how would you enter that?
Cross multiply.
Cross.
But we're gonna reduce it first because you can have your, since you're both inches and if reducing it both is divisible by 3, make the original number 1 and then the secondary 4.
Yep, you can simplify before, sure. So that's an option, or you can just enter it to, so whenever you have anything on the bottom, that's division. Whenever you have anything on the top, that's multiplication. So if you don't want to do the simplification, Tony,
That's fine.
yeah, okay. Yes, so like Tony was saying, so 3 divided by 12 would be like what you put in your calculator, or you could simplify 1 divided by 4. You'll get the same answer. What I want to emphasize is that if it's on the bottom, you need to divide. So 3 divided by 12. So you get 0.25. Now remember our calculators do not adjust for significant figures. So I'm going to write this answer down. And we're not quite done yet. Now, when you write your answer, it's very important that you write the units. So if you just wrote 0.25 and you went on to the next problem, you would lose points. You'd lose points on sig figs, and you'd also lose points on units. So be careful. For right now, I'm just going to write my units. And I'm going to go on to step 4. So step 4, review sig figs. And write units. And one question that a lot of students will forget to ask themselves, does this answer make sense? Does it just make sense intuitively? Now, for sig figs, you need to base your number of significant figures that you express in your answer. You need to base that off your starting quantity. So if we look at 3, how many significant figures in that? 1. Okay. She gave us an easy one. There are no zeros in it. There are no decimals. I like it. Okay. Now, Our conversion factors we ignore for significant figures, so we don't have to pay attention to those. So we're just looking at the starting quantity. So how many significant figures should our answer have? 1. Excellent. So we need to have 1 sig fig. How would I adjust that to the appropriate number of significant figures? 0.3. Good. Okay. So that is my answer. Questions? Does this answer make sense? Okay, so you have 3 inches. Inches are smaller than feet, so you would expect it to be smaller than your original starting quantity. Okay, let's go on and do more practice. So on a quiz or an exam, I will always give you conversion factors. I won't give you the metric prefix ladder. So that's for you guys to memorize. All right, so let's go through this one. I measure the width of a table to be 2 feet. How many centimeters is that? What's my given?
2 feet.
2 feet. Now, be careful when you write down 2 feet. Are you going to write it just 2 or are you going to write it 2.0?
2.0.
Yes, so you have to be very compulsive. 2.0 feet. And what are we asked to find? How many centimeters? Okay, so let's strategize through this. We have these conversion factors. Do you see any that would apply to this problem? So we centimeters to inches, good. Inches to feet. So it's almost like you're hunting for the conversion factors that you're going to need to use. So when we strategize, this is when we do the solution map. We're going to have, we're going to start off in feet. We're trying to get to centimeters. How are we going to accomplish that? Can you convert directly from feet to centimeters? No. Okay. So what are we going to do then?
Feet to inches and inches to centimeters.
Excellent. Feet to inches, inches to centimeters. Okay. So now we're going to do step 3, where you solve. That's where we write out the starting quantity. What's our starting quantity again?
2.0 feet.
2.0 feet. And I'm going to put this over 1. Now, if you ever come across a conversion factor or a conversion problem where your starting quantity is like miles per gallon, then instead of being over 1, it would be miles over gallons. So you see?
Yeah.
And we'll get to some of those. Okay, so now, how am I going to use my conversion factors properly to convert feet to centimeters?
So you want to put feet on the bottom.
Okay, feet on the bottom. And how many feet? 1. 1 foot is how many inches? 12 inches. Good. Okay? So if we stopped right now, we might get half credit because we're halfway there. But we need to get to centimeters. So how do we get to centimeters?
Just convert everything. So we have to use just centimeter over inch.
Centimeters over inches. Good. Okay. So now when you enter this into your calculator, and I'll put it up here, you're going to put 2.0 times 12 times 2.54. You end up with 60.96. What are the units?
Centimeters.
Good. Very good. How many significant figures would I use? 2. Very good. I start off with 2 sig figs here. So I should end up with 2 sig figs.
So you count the sig figs from the given number?
Yes.
Okay.
Mhm.
Will you give us that table at the top or
Yes.
the table?
Yes. So the table will be given, but won't be what won't be given is the metric prefixes. So the mega, kilo, deci, centi.
Do you have also remember all this? Will all chemistry courses do that?
Yeah. Yeah. So you will have conversion factors given.
Okay.
Yeah. And it may be sometimes that you have to figure out the conversion factor, like from the periodic table, like
Oh,
a molar mass, for instance. So you can convert from grams to moles, that type of thing, which we'll cover later on. Okay. Questions on this one? All right. So now, I want you to work some on your own. I've given you this table here, but try to set it up the way that we have been working on, okay? Okay, so I'm going to go through, if you've worked number 1, I'm just going to go through and write out everything. So you're given 0.20 pounds. You're trying to find how many grams. Your solution map, you're going to go pounds to kilograms to grams. Or you could do pounds to grams. And oftentimes, there is more than one way to come up with a solution because you have all these conversion factors. So I'm going to start out with my starting quantity over 1. It's just 1 unit, just pounds. It didn't say pounds per anything. So pounds, and then I'm going to use this conversion factor right here. 1 pound, 454 grams. You end up with 90.8 grams are your units. So be careful. You can think a lot. Sometimes it's pounds and then write pounds because you're worried pounds. How many sig figs do I use? 2. Very good. So what would my answer be?
91 grams.
91 grams.
Did you skip a step?
I didn't skip a step. I used this conversion factor right here. So
I went from pounds to kilograms to grams.
And you got the same answer, right?
Yes.
Perfect. Okay. Yeah.
And I'm still having trouble with that.
Yes. We're gonna go over that really soon.
Close this door.
You multiply across
And divide.
Divide the bottom.
divide. So if it's, so like in this, since I have 60 on the bottom of one and 60 on the bottom of the other, I would multiply those together. And
Or you
then-
could just divide twice 60.
That's what I did.
Okay. So with this one, 55 miles per hour. Try to find out how many feet per second you're traveling when you go 55 miles per hour. So you're given 55 miles per hour. Writing out your starting quantity like this is key. It's going to be very confusing otherwise if you just write MPH. And sometimes I get students who don't know what per means, so they just kind of smush it all together and the units will work out. It makes it more confusing. So we're trying to find feet per second. Okay, so now when we set up our work, our roadmap or our solution map, it's going to be kind of two conversions going on at the same time. I'm a fan of this. Sometimes students don't like that, and you can do it in 2 steps. Just if you do it in 2 steps, make sure you carry every single digit through, even though they're not significant, to the next step, and then round for your sig figs. Okay, so our starting quantity, 55 miles per hour. You can convert miles to feet, or you can convert hours to seconds. Whichever order you can. It doesn't matter which order you do. What would you like to do first?
The simplest one. Could be hours.
Miles. Yeah, and everybody's different, so it's interesting to see. Like let's just do miles to feet. So 1 mile, 5,280 feet. Okay, so you get your miles canceled out. So now we're in feet. So we're in feet. You know, if that's all you could do on this problem, if this was a test problem, no big deal. Good, maybe like 1 or 2 points out of 5. So it gets you something. Now, we need to convert the denominator or the bottom portion to seconds. So you go hours to minutes to seconds, or you can go hours directly to seconds. Be careful. Sometimes I get students that'll say 1 hour equals 60 seconds. That was a short hour, right? But I think part of it is students will see these problems and they'll panic, and then everything just goes. Yeah, that makes sense. An hour is 60 seconds. So just try to stay calm. Don't panic. Okay, so 1 hour. Now, in order to get that hour to cancel out, you're going to have to multiply by the hour. The 1 hour is going to be on top, and then you have 60 minutes on the bottom. Okay, so if we stop now, we're in feet per minute. So we're 1 step closer to feet per second. So 1 minute is how many seconds? 60 seconds. Okay, so now we've got this canceled out. And our units are feet per second. So in your calculator, to do it this long way that I like, you're going to do 55 times 5,280 divided by 60 divided by 60. Or some students like to multiply everything on the top through, multiply everything on the bottom through, so numerator and the denominator, and then they divide it at the end. You can do that too. I have seen students kind of get confused by that, so that's why I like to do it this way.
That's what you're talking about.
Yes, so I know. 55 times 5,280 divided by 60 divided by 60. Okay. So I get 80.666667 repeating. All right. How many significant figures do I need to have? 1,
2.
2. Any others?
2. Don't we need 2 because the 55 miles is...
The given started with 55, so it's 2 sig figs. Yes. So 2 sig figs. What does that round to?
81.
81. Now, what have I done wrong?
Just
split up the feet.
I don't have a label problem.
Yes, no units. So feet per second. So you can write it like this, or you could write it like FPS. You could write it feet/seconds. Lots of ways to write that. The main thing is we have to have our units. Now I will see students who will set this work up beautifully and they'll round incorrectly. So after all of that, we'll get it incorrect. I've also seen students set the work up beautifully. It's awesome. I can see exactly what they mean, and then they'll enter it incorrectly into their calculator. So that's where entering it twice into your calculator can make a huge difference. So make sure you're entering it twice. Make sure you're getting the same answer. You know, when I'm working these problems with you, it's easy. Oh, okay, yeah, that's the answer I got. But when you're alone on a quiz or an exam, it's just you, and you don't know. So, questions on this one?